In hack assembly, we have A instructions that manipulate the A register of the hack machine. Using @value syntax sets the A register to a specified value, which you can use as data or as an address to RAM. As an address, you can read from or write to that memory location using the M register, which always refers to the memory at the address stored in A. Instead of using raw numbers to set A register, you can use easy to remember alphanumeric symbols, which the assembler automatically translates into numeric values. Hack assembly comes with some predefined symbols you can use right away. When you use a new undefined symbol, it gets automatically assigned the next available RAM address, starting from address 16. You can also use symbols as labels in your source code. These get assigned the ROM address of the instruction right after the label. This is especially useful when you want to jump to a different point in your program without manually keeping track of ROM address of the instructions. To perform actual computations or make decisions, we use C instructions. The hack ALU supports computations like outputting constants 0, 1 or -1, outputting the registers A, M and additionally a D register that holds some data. You can add or subtract one from a register. You can do add and sub as well as logical and or operations between register D and one of the A or M register. The result of a computation can optionally be stored in any combination of the A, D or M registers. You can also use the computation output to decide whether to jump to another instruction. This is done using a jump condition. If the jump condition is true, the program continues execution from the address currently stored in the A register. Otherwise, it moves on to the next instruction. Since jumps use the A register to know where to go, you need to set A before using a jump. You can either hardcode the address or more safely use a label, so that you don't have to worry about addresses changing when you edit your code. Once you've written your assembly code, you run it through the assembler, which translates it into binary instructions. In the CPU emulator, you can see your final source code in the ROM with the symbols replaced by values. This code is ready to be executed by the emulator.